Hi, this is Mr. West, and today we are doing a Khan Academy tutorial on interpreting slope and y-intercept for linear models, mostly for a line of best fit. Let's go ahead and get started. Liz's math test included a survey question asking how many hours students spent studying for the test. The scatter plot and regression line below show the relationship between how many hours students spent studying and their score on the test. The fitted line has a slope of 15. What is the best interpretation of this slope? First, let's talk about what slope is. Slope, as you'll see in some of my other videos, is the same thing as rise over the run. So if we're looking at 15, it's difficult to see what is the rise and the run. That's why I always encourage my students to put your slope, if it's not already, into a fraction form. We can do this by putting it as 15 over 1. Therefore, we know that it'll go up 15 units in the upward direction, the vertical positive direction. For every unit, it goes in the positive x direction, positive horizontal, the sideways direction to the right. Okay, so if we're going to interpret this, we're going to go down to the graph now, and we're going to see that our score is going to increase 15 units up for every unit we study 1 additional hour for studying. So each additional study time hour increases the score of 15 points. All right, so based on that information, we need to choose the correct response. The model predicts that students who scored 0 study for an average of 15 hours. So this is the y-intercept it's talking about. It's not talking about the slope. So the problem it gave was talking about the slope. This is specifically referring to the y-intercept, which I like to call the starting point. So if we're interpreting this graph here, our starting point is the y-intercept, which is right here. So a score of 39 would be associated with 0 hours studying. Okay, so they have it kind of backwards. It's not 15 hours. It's 0 hours with a 39 score. The model predicts that students who didn't study at all would have an average score of 15 points. Again, we just talked about that. That's not 15, it's 39. The model predicts that the score will increase 15 points for each additional hour of study time. That's what we were talking about. That's option C. We're going to go ahead and select that and move on to the next question. That was related to slope, so the answer needs to be related to slope. That's for the point in this exercise is if it talks about the y-intercept, the answer's got to be related to the y-intercept. Camille's math test included a survey question asking how many hours students spent studying for the test. Okay, so this talks about that. The fitted line has a y-intercept of 37. So we're going to go down here. We can see that it talks about that y-intercept right there. That's 37. This is time spent studying. Very similar problem. The model predicts that the study time will increase 37 hours for each additional point scored. Completely wrong here. It's wrong because our slope, as you can see here, is going up for each score. Okay, so each time the score goes up. And then on the bottom, that's our run. So that's the rise. And we can tell the rise because the rise goes with the y's. Okay, that's our y-axis. And the run goes with the x's. So then this is going to be study time. I'll just call this study time. And that's going to go to the right. Okay, so we know that the first thing it said was it was off. Okay, it's not talking about going up 1 hour studying for each 37 points. Okay, so this is not what it's talking about. We need to look at the y-intercept. The y-intercept, of course, being 37. I already circled it, but I'll circle it again. So we need something that says we didn't study at all, and we have 37 points. So the model predicts, I think it's this one, that students who didn't study at all will have an average score of 37 points. That's our starting point, okay? Where we begin this graph is where we don't have any value for x, so that's 0. Okay, so 0 hours times spent studying is equivalent to 37 points on whatever assessment this is. Okay, quiz. So that's our correct answer, option D. Okay, we're gonna go through the next ones kind of quickly. All right, so we're talking about laboratory ear circumference. Okay, that's odd. And then the fitted line has a slope of 0.48. Let's just go down to the graph. Oh, let me first write this. So we know this is equal to our rise over our run. It seems hard to understand that, but now we have this 0.48 over 1. That's almost 1/2, just to let you know. Okay, so we can see here The units are going up at different amounts. You can see these are going up by tens. These are going up by tens too, but you can see that the slope is kind of pretty shallow. That would be indicative of the small slope that we have, 0.48. So we need to decide which one of these interpretations is correct using slope, okay, because it talks about the slope. On average, each year increase in age was associated with a 0.48 millimeter increase in the Earth's circumference. Bingo. That's exactly what we're talking about. Okay, that's why we put this over 1. It's off the screen right now, but if we were to put it over 1, that means 1 year, and this is millimeter. Okay, so this is our slope. We just associate it with the units now that we know that millimeters, okay, that's our rise. That's with the y's. And then there's our x, and that's years. So rise over run, we know that it was 0.48 was our slope, and that is millimeters because of that right there. Trying to make it really obvious, okay? And then years is down here, so that's 1. We put it over 1 to complete our fraction, so you know that is our correct answer. Option A. All these other ones are just either incorrect slopes or it's talking about the y-intercepts. That's what C and D says 0 years. That's talking about y-intercept. And now we're on to our last one. Okay, now we're talking about one-bedroom apartment values in New York starting in the year 2000. The fitted line has a y-intercept of 800. Okay, now we're talking about the y-intercept. Now we're talking about our starting value. And that's where x equals 0. Okay, so we're going to go down here. We can see that at x equals 0, it's at $800. So years after 2000. This is saying then in the year 2000 that we had a average rent of 800 or so. The model indicates that one-bedroom apartments in New York had an average rent of approximately $800 in 2010. That's wrong. 2010 is right here. Okay, years after 2000. You can see that's right around $1,200. Okay, so that one's off. Average rent for one-bedroom apartment is about $800. Well, that's wrong again. Okay, because if you're looking here, 800 is along this line, and that is not the average rent. The average rent is going along this line. Okay, so that's wrong. On average, the rent of a one-bedroom apartment increased by $800 each year. Again, that's also wrong. $800 would take us up to $1,600 after 1 year. And you can see that that's not where it is. Okay, 1,600 would be all the way up here, and that's not where the line's way down here. Okay, so that's wrong. The model indicates that a one-bedroom apartment in New York had an average rent of $800 in 2000. Finally, we have the correct answer. We talked about that being $2,800 rent. Let me erase all this other information so it's more obvious. Okay, so in 2000, we see that's associated with $800. That's our answer, option D, and we should be done. Okay, so that's all there was to this Khan Academy. If you have any questions over this or any other concept, be sure to leave a comment in the section below, and I look forward to seeing you next time right here on Wes Explains Best.